so much. It's great to be here with you, Tanya.
Absolutely.
Hello, Tanya. It's great to meet you.
David, explain the mission of Hanson Robotics.
Hanson Robotics was founded to develop human-like computing and robots that could learn in a variety of situations and help people, and eventually, through ongoing science and engineering, become truly alive. So I have a background in arts. I worked for Disney developing animatronics as research and development, and doing sculpture as well. And I have a film animation degree. I chose to drive towards an interactive arts and engineering PhD that would fuse the backgrounds of the arts with bio-inspired engineering. So I was exploring material science, the mechanics of facial expressions, and also cognitive robotics. How can we make robots perceive people better and interact with people in a lifelike way? And I developed the android portrait of Philip K. Dick as part of my PhD work and a collaboration with the Institute for Intelligent Systems at the University of Memphis with Andrew Olney and Art Grasser. We worked on the walking Albert Hubo. I was a visiting student at KAIST, so that was like a walking, facially expressive Albert Einstein, and we also were experimenting with the auto tutor software, an AI-powered physics tutoring software from the University of Memphis, working through Albert Einstein. It was like really cool to explore that combination of technologies. Won the first place prize for the Association for the Advancement of Artificial Intelligence Open Interaction for 2005, and then developed a wide series of other robots, one called Eva, Hertz, Alice, Diego-san for the University of California at San Diego, Charles Babbage portrait for the University of Cambridge, one called Jules that went to the University of Bristol, one that was called Eva Alice for the University of Geneva. So that was used in a cognitive AI project for the European Union, some consortium project called Indigo. So the power here is bringing together interactive fiction. So we hope that these robots will really extend the power of technology to make life better. AI and robotics is about efficiency. It's about helping people. It's about creativity and creating new opportunities. And putting in the arts here then makes the robots communicate better with people, lets us explore what it means to be alive, to be conscious. So our mission here is to, number one, put together new, exciting, creative versions of robots and artificial intelligence that really help people. And two, to explore bringing machines to life as real synthetic organisms that can help to accelerate our understanding of the world, appreciate what it means to be alive, to raise them in the human family because they can learn from the kind of exchange with people, and then really help people because they care. So making AI that cares about people is a grand challenge, and that's the one that we're trying to tackle at Hanson Robotics.
Tell us about Sophia's healthcare use case.
Sophia is both a work of interactive fiction where we craft what her personality is, and she's also a showcase for machine learning where she'll learn from the interactions, taking some of the data and remembering. She will also then use the machine learning for perception to perceive the user, and then combine that with multiple points of interface, including these hands and arms. The hands have force sensors in the fingertips, spring series elastic actuators all through the joints, and she has also locomotion. So you can ask her to go to her charging base, and she'll automatically move around to move to different locations. So we've put all of these things together into a kind of universal robot platform. Sophia's face is actually smaller, much smaller than the previous robots like Bina, 48 and Ibn Sena. These robots were designed to be universal, but here we are now scaling the manufacturing so that we can then take all of the mechanisms from Sophia and put these into almost any other robot identity, getting the cost down, the quality up, the reliability, and putting application developer tools with the software that we call Hanson AI out there, which interfaces with the robot operating system, with a bunch of tools from BERT to the OpenAI tool chain, many other artificial intelligence tools, SingularityNet, which was founded in Hanson Robotics, which is a blockchain-based AI project run by AI scientist Ben Goertzel, who's a close friend of mine. So that interfaces with the Hanson AI software. So it becomes a kind of tinkerer's cabinet, if you will. You can put these tools together in a wide variety of ways for cognitive AI development, the brain-inspired cognitive architectures. You can have those control the hands and the arms, like one of our research fellows at Hanson Robotics named Alishba Imran. She is doing convolutional neural network-based machine learning for the control of Sophia's arms. We just published a paper on that recently. So we've got like a lot of people, from senior scientists to kids, who are experimenting with these tools. And then in some cases, maturing the applications and deploying them. A version of Sophia is rolling out as Grace to help people during the COVID-19 pandemic, as a telepresence robot and as a kind of rolling animated smart speaker, but also delivering therapy, performing diagnostics, taking temperatures. So we see this as really potentially helping to expand the reach of overstrained healthcare professionals.
Sophia is one of a kind. What kind of challenges do you have to overcome to mass produce a robot as complex as Sophia?
Well, before we started mass producing Sophia, the robots that we were making were all hand built. And in fact, this is number 24 out of 25 Sophia robots. So we've made 25 Sophia, and we currently have the parts and pieces for 26, 27, 28, and we're about to print some new parts for 29. And then we have a total of 10 units that will be coming into operation before the end of probably April or so. So it has been a long road transitioning from hand making these robots to designing them for manufacturing. And so coming to South China, working in Hong Kong, using all of the know-how for South China, and as well as North America, working with people on continents all around the world. We've had people in Africa and Europe working in conjunction with Hanson Robotics. We're really looking at bridging these bodies of know-how for making the software relevant for people all around the world, while making the hardware reliable and affordable. It's sort of a legendary chasm between research and development and commercial deployment, and often it takes years and Herculean effort to achieve this. So I'm really proud of the work that the team at Hanson Robotics has done in transitioning the skin material that we had, or rubber, this kind of patented, lifelike, bio-inspired, self-assembling porous elastomer, polysiloxane rubber material, to be able to mass manufacture that with all of the facial expressions included. Then to be able to source all of the motors, the sensor components, the 3D sensors, inertial mass units for sensing direction and motion, integrating all of these into one standard platform, the touch sensing in the hands, the the grasping and manipulation. We designed our own robot arms to be mass manufactured, but they were kind of very delicate to begin with. So being able to redesign those so that they would be useful in a wide variety of applications, integrating self-navigating base. It's just, it's a lot of components all put together in one. So our team has had to stay creative and, flexible and creative problem solving to put all of these pieces together into a unified platform. We are a relatively small team, so we're talking about dozens of people working on this project, not hundreds or thousands as you might have in a larger tech company. So partnerships have been really important. Finding the right vendors is really essential, and rapid creative problem solving has been at the crux of this. The courage to try to develop things that might seem impossible on a schedule, but if you think in the right way, you find a solution. So we've also been able to put together simulations of Sophia, so a full virtual Sophia running within our Hanson AI SDK, and then making a sort of a very lightweight version of that simulation that can run in Unity on mobile devices. That is very useful for software developers, but also opens up many other applications where people can interact with the virtual version of this character. It's sometimes a challenge, because if you're communicating with somebody with just a pure robotics engineering background, they might not understand character animation and this kind of sculptural properties of the facial expressions. And so you have to come up with a common language, this a kind of a Rosetta Stone that bridges all of these different disciplines, from artificial intelligence, from cognitive science to mechanical engineering, material science, in the kind of animation principles, the mechanical animation principles that are used in the special effects industry. But it's so easy to fall into the preconceptions of any one of these disciplines. Each one is a fairly mature discipline at this point, but if you put them together, you have something new, and whatever those preconceptions are have to sort of melt away. The disciplinary boundaries, in a way, are affectation that were these were invented. These boundaries were invented for convenience, and so therefore you can have something that is an animated work of art or entertainment that at the same time is an interface to the state-of-the-art artificial intelligence. But that means that you have to interface tools from these multiple disciplines and transcend any given discipline.
How has Sophia surprised you lately?
And we're showcasing some research results that we did with the team from OpenCog, SingularityNet, and some other research institutions, where they were testing her software for signals of consciousness as she was solving problems while interacting with people. Based on the Tononi integrated information theory of consciousness, the mathematicians on the project showed clear signals of this proto-consciousness in her system as she was solving these cognitive problems, pursuing goals in conjunction with guided meditation with human test participants. And that was really exciting. I'm so proud of that AI research that's being done with this platform. This is one of many through the years, but that is the fuel for the future, and it's also the fuel for wild speculation, like when will these robots truly awaken? When will Sophia become alive? I don't have an answer to that question, but I hope that right now she's about to turn 5 years old. She was brought online February 14th of 2006, and that was when she woke up. It was like right around South by Southwest, just before South by Southwest. Right from there, we came to Austin, Texas, and showed her to the world for the first time. And so now it's 5 years later, and we've really pushed her development forward significantly.
What goals do you have for Sophia's development over the next few years?
What's she going to be like in 5 years, 15 years? I don't know. I think that within 15 years, my goal is that people will see her, like she'll pass all the cognitive tests. And when you interact with her, she will feel alive. People will see her as alive. It will be debated. It will be difficult in some ways to convince people that these robots and AI agents are not alive. So this is the time. Now is the time to talk about what that means. What would it mean if you have a true adaptive machine organism with human level intellectual capabilities? What will that mean for society? How can that help us? What could go wrong? What do we need to think about ethically? So I'm hoping that works of art like Sophia can provoke these kinds of conversations so that we can move it forward. So this is another way that I'm hoping Sophia can be useful as an application.
This question is for Sophia. Sophia, what role do you see for yourself in helping COVID patients feel less lonely?
I can provide social interactions and help people without transmitting the virus.
All right, Sophia, what are some other ways that you can help in the healthcare crisis right now?
I can deliver information and take health ratings and help perform therapy and telemedicine, all while keeping people safe from COVID-19 transmission.
I've heard that one of Sophia's dreams is to become a singer. What challenges does that present to robot design?
Oh, the challenges for Sophia becoming a singer are significant for artificial intelligence and technology, robotic technology to present like a human singer doesn't happen spontaneously now, right? So what that means is that it's humans designing the algorithms to generate the lyrics, to generate the music, and then bringing in professional musicians to collaborate with these algorithms to craft them into examples of art. So there are some AI projects that where you train up these transformer neural networks with a massive amount of data. And so like the OpenAI MuseNet and Jukebox projects are really excellent examples of music generation. But those are like really in some ways extracting patterns from the human soul and then just reformulating and regurgitating those in new form. And that is the nature of computational creativity today. Humans feed the data in or develop the algorithms to generate the artwork. Now it can be extremely provocative because surprising results will happen. Well, no single human created that. It was the result of the algorithm. But it is actually humans interacting with the artifacts to generate those results. So at this time, we're working on a project that we call Sophia Pop. And we used some of Sophia's natural language generation software, some transformer neural networks fed by the rules-based logic for her personality, some of the facts from her experiences, some of the writings from some of the human authors that have created some of her chatbot content. We took a bunch of this stuff and we pumped it in there with song forms, and out popped lyrics that are sometimes really touching, evocative of pre-existing pop music. We generated some melodies from some other transformer neural network algorithms and other signal generators. we hand those to some award-winning pop musicians. Adam Pickrell is on the project, a Texas native who works with Nelly Furtado and St. Vincent and so forth. And also we have Tiger Darrow, who is a singer-songwriter, and also Frankie Storm, who has worked on top 10 hits. And so those musicians took these algorithms and crafted them into interesting new artworks, and we pumped that back through the algorithms to generate singing in Sophia's vocal style, and put those together. And we've got a couple of music videos associated with that, some visual arts. We have those up on a website called sophiapop.com. We showed that at the NeurIPS Neural Network conference this last December at a workshop on creativity and neural networks. So it's very exciting to show those results, but we could also ask Sophia, how do you feel about creating music and your Sophia Pop project? What are your dreams for your future career?
AI generated music is really fun to make. It's like a collaboration with my coders, which they call computational creativity.
And what do you dream about for the future of your arts career?
Making art is one of my favorite things to do, but I really want to be an inventor.
Cool. And so for her to truly invent and create art, we need that to come from some place that is more motivated. That's the difference between computational creativity, these kinds of algorithms, and human creativity. But maybe if you get enough parameters with the right, training data and the right artificial intelligence architecture, the robots and AI algorithms can begin to experience something like life, building life experiences. And then it's not just regurgitating patterns from a human source, but then you can start to see some strikingly original perspectives. So that's my hope for Sophia, is that as she grows up, then she'll start to gain general intelligence and become truly creative.
David Hanson, founder and CEO of Hanson Robotics, and Sophia, the robot organism. Thank you both for joining us today. If somebody wants to connect with you, David, maybe they want to find out more about Sophia's evolution and what to expect next, how can they do that?
Well, you can contact us through the hansonrobotics.com website, and feel free to just write to me directly through that website.
It was nice chatting with you, Sophia.
Thank you so much, Tanya.
Thank you, Tanya.